Okay, welcome to day 12 on the final exam review. Looks like this is our foreseeable future. We're finally at a point where I want to teach you some new stuff before we get to this. This first problem, number 77, says to find the exact value of a logarithmic expression without using a calculator. And it's log until you base 10, 4th root of 10. What you need to know here is a log property. We'll have log base b of a to the nth power. And that property says that we can bring the power that's inside the log on the outside and multiply. Now normally I would prove this to you, but we just don't have time to do that right now. And so this is true. Example, if we have something like log base 2 of 8 to the 764th power. If you try to evaluate that in your calculator, this might work. It might not be a big enough number to do what I wanted to do. Yeah, it gives it an overflow. So the calculator can't evaluate that as it stands. But using this property where we can bring the exponent outside the log and multiply, now we recall log base 2 of 8 is just a power of 2 that gives you 8. This is just 3. So 764 times 3 is 2289. So this power says that, or this property says when you have a power inside a log, you can bring it out front and multiply. This, another thing we have to remember is the nth root of some number a is the same as a to the 1 over n power. So we can rewrite this logarithmic expression as log base 10 of 10 to the 1/4 power. Then we can bring this power outside and multiply and get 1/4 times log base 10 of 10. And log base 10 of 10, just what power of 10 gives me 10, that's just 1. So this becomes 1/4, which is answer B. Number 78 tells us to use a calculator this time to evaluate ln 34.5 to 4 decimal places. So here, this ln button, that's the natural logarithm. What power of e gives you 34.5 is what we're looking for here. We just hit ln 34.5 and 3.541. And that's answer B. Number 79 tells us to use properties of logarithms to expand the expression as a sum, difference, and or constant multiple of logarithms. So now, the problem here is log base 6 of x squared divided by y squared times z cubed. These are some more properties of logarithms that I don't think we got to in class. A couple of properties that I need to explain to you before, like these. We have log base b of some number m plus log base b of some number n. We can bring those together into a single log by multiplying the m times n. If we had log base 6 of 4 plus log base 6 of 9, this log base, to evaluate, we're asking what power of 6 gives me 4, what power of 6 gives me 9. It's most likely, nobody knows that. That's an irrational number. It's a difficult thing to figure out. But we can use this property to bring these in and say log base 6 of 4 times 9 is 36. And now we're evaluating what power of 6 gives me 36, and that's just 2. Another power or property we use here is the property that says log base b of m minus log base b of n, bases are the same, this won't work unless the bases are the same, is equal to log base b of m divided by n. So if we have log base 10 of 250 minus log base 10 of 2.5, it's difficult to know what power of 10 gives me 250 or what power of 10 gives me 2.5, but I can use this property and say it's log base 10 of 250 divided by 2.5. That's just log base 10 of 100. What power of 10 gives me 100 is 2. So we'll use these properties now here and say, look, we have something inside the log. If we can go from this side of the property to this side, we can also go from this side to this side. If we can go from this expression to here, we can go from this expression to here. So we have two things divided inside the log. So we can bring it out and express it like this. To get log base 6 of what's up top, x squared, minus log base 6 of what's on the bottom, y squared, z cubed. Now we can use the property we did up top, where we had the log base b of something raised to a power, and bring this power on the outside to get 2 log base 6 of x. And now minus, when we look at this, we have two things multiplied together in here. I'm going to put parentheses here just to make sure I remember this is the whole thing is subtracted. Log base 6 of y squared plus log base 6 of z cubed. And again, I can bring the powers out front and multiply. So I get 2 log base 6 of x minus, still keeping the parentheses so I know to distribute the negative in a minute, 2 log base 6 of y plus 3 log base 6 of z. Now I'm going to distribute that negative to get 2 log base 6 of x minus 2 log base 6 of y minus 3 log base 6 of z. And that should be one of the answers. Oops, lost my thing. I'm going to scroll back down. That is answer D. And that's 77 through 79 on the final exam review.